Hello everyone. In this video we are going to look at a program which takes as argument some objects and also returns an object. So this program is for a fractions. So we know a fraction consists of numerator and a denominator. So we have created a class called fraction with two integer instance variables, numerator and denominator, num and den. Then here I have a constructor. I have a simple constructor with two arguments, so which is passing two primitive data types, n variables, n and d, and n is assigned to the numerator, and denominator, for the denominator we are checking if n is equal to 0. Okay, if n is equal to 0, we cannot have a fraction with a denominator as 0, so we are by default we are making the value to 1, and then this value is assigned to the denominator. So this is a regular constructor, two argument constructor. Then we have a copy constructor out here, fraction, which takes as argument an object f, and then it assigns the values of the numerator of the object f to the current object numerator and denominator of the object f to the current object's denominator. So two constructors we have. So this one, the second one here is the copy constructor, and we have the two methods here, set denominator and get denominators. These are the set and the get methods. Okay, we are not going to use them now. What is important here is this particular method. So if you look at this, we have, say, this is a method called add. The name of the method is add. So if you recall from methods, the first thing that appears here, other than public, private and so on, is the return type. So the return type here is what? It's a object, it's a class fraction. So that means this function add, it returns a fraction, and it takes as argument two fraction objects, op1 and op2. So the method add takes as argument two objects and returns also an object. So what exactly does this method do? So add method here, it takes two fraction objects and adds them up. Now if you can recall again from your school classes, addition of fractions. So the numerator of the sum of two fractions would be the product of the numerator of the first and second and the denominator of the second, and plus numerator of the second and denominator of the first. Okay, so this I leave it to you to find out how this works. Okay, just take two fractions with numerator and denominator and try to sum them up. And for the denominator of the resultant, it would be some product of the two denominators. So op1 is my first fraction which has a numerator and denominator. op2 is my second fraction which has a numerator and denominator. Now for the return value, for the result where the sum of the sum fraction would be stored, we have created a local variable f here, which is of type fraction, and we have initialized the numerator and denominator to 1. Okay, because if we don't assign anything, it will give you a null pointer exception, or it may not even compile because you have not assigned any value, or we have not allocated any memory. So f is going to be the result that we are going to, that is the sum of the two fractions that we are going to return. So f dot numerator, the numerator of the sum would be, this is our logic, operand numerator of the first operand into denominator of the second plus numerator of the second into denominator of the first. So this would give me the numerator of the result, and for the denominator of the result we have, okay, we have product of the denominators of the two operands. And finally we have, after these two steps are executed, in f we have the numerator of the sum and the denominator of the sum of the two fractions. and finally we are going to return the object, so return f. So just like we return any primitive variable, we are returning this reference variable f. Okay, now let us see the point from the place from where this is called. So this is our test fraction class, and inside the main we have defined a fraction f1 which is 10 and 2. So 10 by 2, this is simply printing the value. Then fraction, the second fraction, that is 3 by 7. So what we are going to find out is 10 by 2 plus 3 by 7. So here also we are printing the value. Okay, so second fraction is f2.num plus, this is just to show that it's a fraction, so we put a slash here, and then f2.denominator. Then you can see finally what we are doing, we are calling f1.add. We are adding f1. Now here this is a little bit tricky in the sense that why do we need to call it using f1? Okay, so I'll come to this in a while. So because you can see add is a method of, add here is a method of the fraction class. So I cannot call it directly, I have to call it with an object of that class. So I have two objects of that class, f1 and f2. So I can call it either with f1 or I can call it with f2. So here I choose to call it with f1. So I'm calling with f1, and what arguments are we giving? We are giving the arguments of these two objects, f1 and f2. So f1 would be copied to op1 and f2 would be copied to op2. Okay, and this addition will be done, an object f would be returned. Now this return value would be here. When the method completes execution, the return value will come here. It has to be assigned to an object of the same type or a variable of the same type. So since it is returning a fraction object, we are creating a fraction object f3 here, which will hold the return value. So f is returned from here, and in this main function, because this is a separate method, you will not be able to access f from main. So the value which is returned is stored in the variable f3. So f returned stored in f3. So f and f3 will refer to the same object. And finally what we are doing, we are printing the sum, that is the sum of the two fractions. So let us run this and see. So let's compile test fraction. Okay, no errors. So the first one I had created, first fraction was 10 by 2, second fraction was 3 by 7. So sum of the two fraction is 76 by 14. So you can check out whether this is correct or not. Alright, so coming back to our program here. So you can see here that we have called it with f1. We have called the method add with f1. So we have seen how a function or a method can take arguments which are objects and can also return an object. Okay, just one modification let me make here. Now I had called the method add with f1. Okay, let me call it with f2 and see what happens. Okay, let's call it with f2. So we will run this again, compile first since I have made a modification to the program. Then let us run this. So you see it works perfectly fine if I call it with f1 or I call it with f2. So it doesn't make any difference whether I call it with f1 and f2, because I am not, this function that I have written is not bothered with who is calling the method. So let us modify this again now. Okay, let us modify this so that it will matter who is calling the method. So I'll just copy paste again. I'll just copy paste this, and now instead of having two arguments, I'm going to give one argument only. So fraction OP. Okay, so everything is same, except now I have only one argument. So what will I add? What am I going to add if I have only one argument? Here I had two arguments, so I had added the two and returned the value. Here I have only one argument. So where is the first argument? So we can modify this code so that the first argument will be the fraction object which calls this method. So here f1, we had used f2 to call the method, but we were not bothered with who is calling it. We were only bothered with what is being sent. So f1 and f2 were the arguments, were the fractions being sent, so we added these two. Now we are going to modify this method add. All right, and what we are going to do is we are going to see that the first object which is passed, that is the first argument, and we give only one argument here. So the addition would be addition of, say, f1 and the one who is calling it, f2. Okay, so let us modify this. So first fraction, I have to create a fraction object. This is going to hold the result. So f.num now would be operator. First it was first operator. Now our first operand is the current object. So the current object we refer to as this, using the this pointer or this keyword. So the first argument would be the current object, so this dot num, and second operand would be simply, I have only one op. Okay, so same here, in place of op1 we will put this. So this refers to the current object. Current object means the object which is calling this method. So similarly here also I will put this, and then here instead of op2 I have op. So how we have modified this program? Now we have modified this method, add this and this. All right, so this dot num now is the numerator of the current object, and this is the one, this is the denominator of the object which we are passing as argument. Let us call this method now. So here this is the first one which remains. Okay, I'm going to call this again. Let's say okay, so let me call it f4. I'm going to call it with f1. Okay, and here I have to give only one argument, so I'm giving f2. So here this is, I'll change it to f4. This is the first final one, f4 here. So I have f3 which is taking two arguments, and f4 which is now we are running it with two arguments. So f1 add f2. Save. Let us execute. So compiled, run. So you see both of these are giving the same result. Because this is addition, there is absolutely no change in the result. Okay, so what you can see in this function is that I don't need to give this. I don't need to give two arguments in this example. Okay, so I can just call it in this manner. So when I call it with f1, then it is doing f1 plus f2. I can again do the same. So let me again put another variable here, f5, and here let me call it with f2 and give f1 here. So f5 here would be, now f5 would be the result of f2 plus f1. f2 plus f1, so same thing, compile, run. So it's the same. The problem would be, or you'll see the difference if we are subtracting. So if I just do subtract, you'll find that this will make a difference. Now some things to note here. Okay, you can see in this function or in this class fraction, I have two constructors that we had already seen before. One is this constructor with two arguments, and the other is this constructor with one argument. Okay. Similarly, I have two functions with the same name. Add two functions with the same name. So what this means is that inside the class I can have more than one function having the same name. But how do they differ? They have the same return type, but they have different number and types of arguments. They have two different types, numbers and types of arguments. So you will see here that how will the compiler know which add to call? Here I am calling the first add method, here I am calling the second add method. Okay, the code is different. This code and this code is different. Okay, so how will the compiler know which one to execute? It will know this by looking at the number and the type of the arguments. So here it is taking two arguments, so it will try to find a match. Two arguments, yes, so it will execute this. And here it is finding one argument, okay, one argument for this, so it will go and execute this method. So this process by which you can have multiple methods inside a class with the same name but different number and type of arguments, also the return type also may be different. This is known as overloading or method overloading. Let me just write it down here. Method overloading. So this is your method overloading. So here again two things we have seen. One is method overloading and the other is how a method can return an object.